G'day! In clay target shooting, the target is released and then the shooter's bullet hits the target. In this video, we will solve equations about the movement of those two objects at the same time so that we can predict if they will hit or miss, and if they hit, where they will collide. Now this example's about clay target shooting, but the same math applies to aircraft, missiles, spacecraft, machinery, and so much more. To work out if the bullet will hit the target, what we need to know first is the equations of the direction of movement of the two objects, like this. Then we solve the equations simultaneously, that is, at the same time, to work out where they collide. Now let's see the two equations. The equation for the direction of the target is y equals 3x. The equation for the direction of the bullet is 2y equals 4x plus 10. Will they collide? The value of the x and the value of the y must fit both equations. What that means is if y equals 3x in the first equation, y must also equal 3x in the second equation. We substitute 3x to where y is in the second equation. So 2 times 3x equals 4x plus 10. That's 6x equals 4x plus 10. Now subtract 4x from both sides of the equation. 2x equals 10. Then divide both sides of the equation by 2, and x equals 5. We have one more step to find out what y is. We know that x is 5. So if we substitute 5 to where x is in either of the two original equations, we will find out what y is. But which of the original equations do we choose? Well, it doesn't matter, but it would be sensible to choose the simpler equation like y equals 3x. So y equals 3x, that's 3 times 5, so y equals 15. The target and the bullet will collide, where the coordinates are where x equals 5 and y equals 15. Let's do another example of clay target shooting. This time, the equation for the direction of the target is y equals x plus 4. The equation for the direction of the bullet is x plus y equals 10. Remember that the value of the x and the value of the y must fit both equations. What that means is that if y equals x plus 4 in the first equation, y must also equal x plus 4 in the second equation. We substitute x plus 4 to where y is in the second equation. So x plus 4 equals 10. That's 2x plus 4 equals 10. Subtract 4 from both sides, and 2x equals 6. Then divide both sides by 2, and x equals 3. We have one more step to find out what y is. We know that x is 3. If we substitute 3 to where x is in either of the two original equations, we will find out what y is. It doesn't matter which original equation we choose. We'll choose the simpler equation where y equals x plus 4. So y equals x plus 4, that's 3 plus 4, so y equals 7. The target and the bullet will collide, where the coordinates are where x equals 3 and y equals 7. Aircraft preparing to land at airports must not collide. If the aircraft about to land are flying on a possible collision course, an air traffic controller will redirect the aircraft. In this example, here are the equations of the direction of two aircraft about to land at an airport. The equation for the first aircraft is 2x plus y equals 7. The equation for the second aircraft is x equals 2y plus 1. 2 times x will become 2 times 2y plus 1 in parentheses plus y equals 7. We multiply what is in parentheses by the 2 outside. That's 4y plus 2 plus y equals 7. We simplify that to 5y plus 2 equals 7. Now subtract 2 from both sides to get 5y equals 5. Then divide by 5 on both sides to get y equals 1. There's one more step to find x. So 2x plus y equals 7. We know that y equals 1, so 2x plus 1 equals 7. Subtract 1 from both sides to get 2x equals 6. Divide both sides by 2 to get x equals 3. The two aircraft could collide where the coordinates are where x equals 3 and y equals 1. Thankfully, the air traffic controller can redirect the aircraft to avoid a crash. Thank you for watching.